Good morning everyone. Today we are going to see one of the next theory, which is the Ohm's law. Generally Ohm's law is the important because it gives the relation between the potential difference and the electric current, which we have seen in the previous lectures, right? The electric current and the potential difference both are related to each other that we have seen in the previous lectures. Like if you want to just produce an electricity or electric current wants to be flow from the conductor, then there should be a difference of potential. Then that electric current can flow in a conductor. But what is the exact relation between both of them, which is given by Ohm's, right? So this law is known as Ohm's law. Generally, with the help of Ohm's law, we get one another thing which is related to the electric current, which is known as resistance. This generally restrict the flow of electric current. If the resistance is more, the electric current passing from the conductor becomes less, and if the resistance is less, then the electric current passing from the conductor is higher. So according to it, generally this resistance controls the electric current, how much should be flow from the conductor, which is also given by the Ohm's law. So today's our topic is Ohm's law, which is an important topic for us because from this theory, generally three different types of questions can be asked in an exam. The questions can be of 2 marks or 3 marks. Sometimes they ask for 2 marks, like draw a circuit diagram from the Ohm's law. So you have to generally draw circuit diagram, only a circuit diagram of Ohm's law, which gives you a 2 marks. But you have to indicate a single thing in it, right? Then and only then you get a 2 marks. Not only that, sometimes they ask for the Ohm's law, write the Ohm's law and give a conclusion of the Ohm's law. Then you have to give a conclusion of Ohm's law. And sometimes for the 3 marks, they can ask you for write a practical for Ohm's law. Then you have to write a whole practical of Ohm's law. So I am just telling you or teaching you a whole practical of Ohm's law, in which you get the conclusions also, you get the figure also, and you get the Ohm's law also, right? So first of all, I am going to write the Ohm's law. What is the Ohm's law? Generally, total current passing from a conductor is directly proportional to the potential difference between two ends of conductor at constant temperature. That is, if you are thinking about the one conductor, here it is one conductor, in which the electric current is passing. Then the electric current which is passing from it, if you are thinking that I, then it is directly proportional to the voltage difference between the two ends of the conductor. If the conductor's voltage difference is V. Generally, you have to remember that if you want to find out the current, then you have to connect this conductor with a meter in series like that. And if you want to find out the voltage difference, you have to connect the voltmeter in a parallel to that conductor like that at the 2 ends of a conductor, and you get the voltage difference. So from that you can say that these two are proportional to each other. These two are proportional to each other. So you can say that the V is proportional to I. If we remove the proportionality, we get 2 things. One is equal to and one another is the constant. So there is a V is equal to constant and I As a constant, you have to take a capital R. So it gives you V is equal to R into I, where the R is the resistance of a conductor, which is known as the resistance of a conductor. If I take this priority to R and I just take it, this I on the another side, then we get V by I is equal to R. So what is the equation? R is equal to V by I. So this R is directly proportional to the V, while it is inversely proportional to the R. So if the R is increased, the I will be decreases, and if the R is decreases, the I will be increases, because both are inversely proportional to each other. From this one, you can say that the SI unit of the R is, for the V it is volt, and for the I it is ampere. So the SI unit of resistance is volt per ampere, but due to the ohm, the SI unit is ohm. It's a ohm, and here it is the sign of ohm. Here it is the sign of ohm. This resistance generally depends on the atmosphere, like a temperature and pressure. Just because of that, we are taking here at a constant temperature. If the temperature changes, then both will never be proportional to each other, because this resistance a little bit change due to the temperature and the pressure of atmosphere sometimes, right? And not only that, it is also depends on the matter of a conductor. Like if you take the copper, then the resistance is less. If you take a silver, the resistance becomes more less, right? If you take a iron, then resistance is higher than the copper. Like that, every metal has a different resistance. Every metal has a different resistance. But for the iron rod or iron string, the resistance is same for the same amount of cross section. Understand? So the resistance is changed according to the material of a conductor, and sometimes it is changed due to the temperature and the pressure. Understand? So generally this resistance is depends on these two factors: the temperature, pressure, and the means of physical condition of atmosphere, right? And the second one is the matter present in a conductor. So here it is the resistance, which is given by ohm with the help of Ohm's law, right? Which says that the total current passing from the conductor is directly proportional to the potential difference between the two ends of the conductor at a constant temperature. So it gives you a V proportional to I, which is equal to V is equal to constant I, where the constant is R, which is the resistance, and the SI unit of resistance is a ohm, which generally denoted by omega. This sign is known as omega, but the SI unit is ohm. If someone asking you about the SI unit of resistance, then you have to say ohm. But if what is the sign of SI unit of resistance, then it is a omega. Understand? So here it is the Ohm's law. If you want to just define the 1 ohm, then you know that you have to take a 1 volt and 1 ampere. If the 1 ampere of current is passing from the conductor who has a potential difference is 1 volt, then the resistance of the conductor is known as a 1 ohm. Understand? If you put a 1 ampere instead of the current and a 1 volt instead of a potential difference, you get the resistance, which is 1 ohm. So, if the 1 ampere of current is passing from the conductor who is in a 1 volt potential difference, then the resistance of the conductor is said to be a 1 ohm. So here it is the Ohm's law. Here it is the Ohm's law. Now the practical for this ohm, right? Okay. So what is the practical? For that, you have to take some of the apparatus. Like we need a 1 ammeter, 1 voltmeter. As you know that we need a V and I. As the V is proportional to I, and you have to just say that the V is always proportional to I. Then you have to measure the V and I. So first of all, we need a voltmeter for measuring a V. Then we need a ammeter. electric current is passing. But as you know that at here we need a resistance also, because if the conductor is purely conductive, then the resistance is very less, which can't be generally recognized by us. So we need a resistor instead of conductor, which is generally made up of nickel. Which is generally made up of nickel. Nickel is the alloy of nickel, chromium and manganese. And as you know that iron is always there in everywhere, so there is a iron also present in a nickel. So the nickel is the alloy of 4 different metals. One is the nickel, chromium, manganese and the iron, and all gives you a one nickel, which is generally used as a resistor in a circuit. For making resistor we are using a nickel, right? So we need our nickel wire as a resistor. We need an ammeter to find out the current, the amount of current is flowing from the circuit. We need a voltmeter which gives us the value of potential difference between this resistor, and we need a one source of electric current, as we are taking here a battery, a variable battery that we can change the value of electric current. Understand? So at here we are using a circuit in which there is one nickel wire. The resistance is R, right? Here it is ammeter. Here it is a variable batteries. Variable batteries gives you like that. So if you connect that here, all the batteries will be connected. If you connect 4 of them, you can put any numbers of batteries at here. I'm just putting 5 as you wish, right? So like that, you can change the batteries. And now for finding voltage difference, as I said you, then you have to connect it parallel to the conductor. So it should be at here. So here it is the voltmeter. And now the main thing is the poles. In a batteries, generally the plus is at here and the minus is at here. The bigger line as a plus and the smaller line as a minus. So whenever you connect these two apparatus, the plus should be connected with the plus at here, and the minus should be connected at the minus here. If here it is minus, here it is plus. If here it is plus, here it is minus. Then your circuit is right, otherwise not. Now battery is connected, so the current is also flowing from it, which is I. So here it is the whole circuit of Ohm's law, in which you have to give a different power with the help of battery, which gives you the different value of A and the V, right? Current and the voltage is given to you by these two apparatus. Now what you have to do? First of all, you have to arrange all the apparatus as per figure. Then connect the whole circuit with the one battery. Now some of the current is passing from it. Now observe the ammeter and the voltmeter. You have to know the readings of it in a tab. Like if here it is V and here it is I. If the I is 5 ampere, during that time the voltage, which is I will take it a smaller one, then the voltage is 2 volt. During that time, if it is 0.5. Now I am connect the two batteries. As I connect the two batteries, then the voltage difference becomes higher, and if it becomes 4, it becomes 1. Then 6. Then 8. Right? Here it is the value of different voltage for the different current. If I just take the V by I, 2 by 0.5, 20 by 5, it gives you a 4. Like that, V is 4, 1, it's a 4. Like that, V is 6, 1.5 by 15, 3. Oh, there is some problem. Value is different at here. Oh, yeah, right. Here it is a 2. Right? So it's a 4 ohm. Like that, a V by I. 8 by 2, which gives you a 4 ohm. So always, this one is same. The V by I. Ratio is always same, which gives you the value of R. For the single material, the R is always same, which is 4 ohm. So like that you can perform the practical. What you have to do, first of all, you have to arrange all the apparatus as per shown in figure. Then you have to connect a one battery and just let electric current flow from it. Now you have to note the readings of ammeter and the voltmeter. Now repeat this whole practical with the help of 2 batteries, 3 batteries, 4 batteries, 5 batteries, etc. And note all the readings of V and I as per the voltage. Then you get a different value of V and a different value of I. If you draw a graph with the help of V and I, then you get the graph as a straight line, which says that this V and I ratio is always same. So what are the conclusion of it? The conclusion is that if the voltage drop increases, if it is increases, the current is also increased in a proportion. Like it doubles, then it is also doubles. And here, always the same difference. So here it is also the same difference. Understand? So it always change as per the proportion of voltage drop. The graph of V and I, V opposite to I, is a straight line. And the third conclusion is that the ratio of V by I is always same. So here it is the conclusion of Ohm's law. The first conclusion is that as the voltage drop increases, the current flowing from the circuit is increased in a proportion, right? The graph of V opposite to the I is a straight line, and the ratio of V by I is always constant. So here it is the conclusion. So here it is your Ohm's law. The Ohm's law, the practical of Ohm's law, and sometimes they can ask you a circuit diagram of Ohm's law. So I am just finishing today's lecture here. The another topics which is related to the Ohm's law will we see in the next lecture. Thank you.